of today is the future of maths. Now, in a very short time, major innovations in technology have really started to appear, and actually that's really started to change the way in which we teach our children, but also the way in which our students learn. Now, we have to be really mindful because our students now have so much exposure to so many different types of technology out there, and I feel that part of our role in education now is to really hone those digital skills, because we really want to add value to their learning, so that actually when they go into adulthood, they've already got this access to a whole range of digital skills that they can then use time to time. So we're going to go on a journey this morning, and you're going to come on this journey with me, and we're going to actually go on this journey to solving a problem. Okay, it's a rich problem. And I call it a rich problem because it's low floor, high ceiling. I don't know if you've heard of that term. Low floor means that many of the students in your classroom will be able to access this problem. High ceiling because it's rich enough that actually we're not all necessarily going to access this problem at one level. It's got that breadth, it's got that depth, that actually we can challenge our students at all different levels to really move them on with their learning. We're also going to look at technology and actually think about the past and the present and the future and how we can really embrace that within our educational setting. And we're going to go and have a tiny look at one particular technology, which is the virtual tutor, which I believe is the future of maths. So, are you ready to come on this journey with me? Now, like you, I want to be the most effective teacher possible. And I know the potential that technology has, to develop students' understanding, to stimulate their interest, but also to increase their potential in mathematics. And I believe technology can really help us do that. But we need to think carefully about the different technologies that we're going to use. Now, before we go any further, I don't know if any of you have got... Oh, that's not a good sign, is it? Technology already messing up. Right, okay, we're there. I don't know if any of you have got any iPhones on you, have you got any tablets, have you got some kind of digital technology. What I would like you to do now is just to load this page for me, www.menti.com. Once it's loaded, leave it, and a bit later we're going to, if we have time, access this as part of our workshop. Okay, just before we get started, we're going to solve a problem. It's called Sum to 15, and you'll notice that on your tables you have got some manipulatives. I've put some number cards on your tables, you've got some dot cards, you've got some playing cards, and you've also got some numicon. I want you to choose one of those in pairs. So choose one of those manipulatives. When you've chosen the manipulative you want to use, I then want you in your pair, to actually lay those cards or the numicon pieces, whatever you've chosen, lay them out in front of you so you can see the numbers. You've got the numbers 1 to 9. Okay, so you must do this with a partner. And what I want you to do now is it's a game. And you're going to take it in turns to pick up one of the 1 to 9 cards or numicon that you've got in front of you. When you've picked up one, then your partner picks up one. And you keep going, and it's the first person to have 3 numbers that sum to 15. Simple as that. Okay, so have a go. So take it in turns to pick up a card. Sorry? No, you must see the numbers. We want to make choices so you can see the numbers. Absolutely. You keep going until you've got 3 cards that sum to 15. It doesn't matter if you've got 5 cards, as long as 3 of those cards sum to 15. Sorry? 2 doesn't count. 2 does... Must have 3 numbers that sum to 15. Are you okay? Ah, you've done it. Well done. Ah, okay. Okay, let me stop you there for a minute, because it's quite interesting when you do this. When I've done this with my students, to begin with, they're so focused on, I'm going to win this, and they're just looking at the cards that they are picking up. But hopefully you've noticed it's not as easy as that, because actually we need to focus on what our opponent is doing as well. Okay, so, and when I ask them, what's your strategy? How are you choosing your numbers? They have just been focused on picking up some numbers and trying to win, and that's been their strategy. So what I would do at this point is I would say to my students, okay, start again. Is there a particular card you want to start with? So is it best to start with a 1? Is it best to start with a 5? Is it best to start with a 9? Get them to start thinking about the cards they're picking up. I might also ask them, once you've picked up the first card, is there a particular order then you want to pick up the other cards? Another question is, because there's only 2 of you, is it an advantage if you start first? Or are you best to start second? So what we're starting to do now is taking the learning a bit deeper, because I'm wanting them to start thinking about what they're actually doing. Because I want them to start realizing they've got to focus on their opponent as well as what they're doing as well. So I'm going to give you another go at having a go at playing this. But whilst you're doing it, I now want you to think about, can you find a winning strategy? Okay, so I'll give you just a couple of minutes to have another go at this with your partner. And we're going to come back to this. So if you think you're finding a winning strategy, keep those thoughts, and we're going to come back to that in a minute. Okay. Okay, I've already said technology is absolutely everywhere. It's integral to our lives, and actually, we live with technology, we play with technology, we learn with technology, we work with technology. It's absolutely everywhere. And what I find fascinating, I'm old. I've been teaching for over 30 years. When I first started teaching, I remember one computer came into my classroom on a trolley for half a day a week. That was technology then. We had lots of other technologies, but not necessarily the digital technology. What I am surprised about now is a 6-year-old can't tie their shoelaces, but actually probably has more knowledge about digital technology than their parents. It's expanding so quickly. So we need to embrace that, and I really feel we need to make sure that we're bringing that into the classroom as well. But I think we need to think carefully about how we're doing that, because I think it must enhance the learning and not just tick a box because we've used some technology in the classroom. So we need to think carefully about it. So to see the future of maths, what we need to look at is the past. Oh, sorry, we've gone too quickly. So actually, if we think about technology, it helps us to be able to do things faster, quicker, and it helps us to work things out. And if you think back to mathematics, and if we go back in the past, if we go right back to very early civilization, they were using technology then. To begin with, it might have been their fingers, but then, of course, we've only got 10 fingers. And actually, if you want to look at number and it goes beyond 10, what are you going to use? So they started to use sticks, stones, bones to help them. They represented a particular value. Going back to the Romans, they actually used a bead board. So, this is all technology. We can see how it's advancing. In the 16th century, Pascal with his adder. So all these technologies started to develop. But it wasn't actually until the 1980s, which is not that long ago, that we really started to embrace technology and manipulatives and use them much more within the classroom. So it's actually, almost the time that I've been teaching, actually, which is quite frightening. But look how advanced it's gone in those last 30 years. So what I want you to think about, we're going to do a very quick activity. I don't know if you've done something like this before. It's called Diamond 9. And on your tables, there are some Post-its. I want you to grab a Post-it. And I've said to think of 3 technologies. Maybe let's just, for time's sake, maybe just think of technologies that you use in the classroom. And I want you to pick one technology that you use in the classroom that you feel has the biggest impact on your students' learning. Now, I know we're all primary here, or most of us are, but actually there's obviously a whole age range we have here as well. So it might be you're choosing different things, that doesn't matter. Could you jot, each of you, on a Post-it, what you feel the technology you use in the classroom has the biggest impact on learning? And when you've done that, share it with your table. And then what I want you to do, I don't know if there's going to be enough of us on each of the tables, but I want you to actually then have a very quick chat. I'm going to give you a couple of minutes and decide as a table what you feel has the biggest impact. You may agree, you may not, and which has the least impact on your students' learning. Okay, just a couple of minutes to... you can introduce yourselves to each other on the tables and then have a discussion about the technologies. But if I go back to the actual problem that I shared with you at the beginning, and I think about what technologies would have actually supported the students in playing that game, actually probably the tangible resources that you've been using on the table would be what I would use. I don't know if anyone has a digital technology that could replace that, but I think actually there is a place still for those tangible resources within our classroom as well. But in a minute, when we come to think further about the problem we've been exploring, when I'm then wanting to engage all of my students in feedback, that's when the technologies really come into their own. That's when I might use an interactive whiteboard or I might use a visualizer. So actually, when students are feeding back to me their responses about finding a winning strategy, I can actually then use the interactive whiteboard to note down all the things that they're saying. So you've got that visual representation then to help the students. Or I might have a visualizer where I can show, or an iPad where I'm showing things as well. So we do know that they really do support our classroom teaching and the actual learning. But what I want us to think about now is the problem that we've just been working on. And we can't just give students problems. We need to think carefully about the problems that we give them. Because in order to be able to access a problem, they're going to require certain skills. So that's why we need to think carefully about it. So what I want you to think about now, and I'm just sharing lots of different strategies with you because these are nice to go back and use in the classroom. I've realised the strategy I've chosen here probably is totally irrelevant for us here in Dubai because I've got a snowballing effect. And you don't have snow here, do you, like we do in the UK? Anyway, if I just explain snow to you, when you make a snowball, if you put it on the ground and roll it in the snow, the rest of the snow around sticks to that snowball and it starts to get bigger and bigger. That's how we build our snowmen. Okay, so we're going to do a snowballing activity now because I want you to, very quickly, I'm only going to give you 30 seconds, not long, but very quickly in pairs, I want you to think about, in order to do the problem that you've just been doing, what do students need to know? What skills do they need, okay, in order to be able to actually complete that problem? Once you've done that in pairs, share it with another pair, share it with your table. That's the idea, because the snowball's getting bigger and bigger, your groups are getting bigger and bigger. So, 30 seconds, not going to give you long. What skills do they need to access this problem? Okay, so actually they need some knowledge of number facts. If they haven't got that knowledge of number facts, what they're going to end up doing, starting to count on their fingers. It's going to be a very slow, laborious game if they're doing that. So they need some knowledge of their number facts.
They also need to be able to do some mental calculation as well. If they're struggling to do that mental calculation, and once again they're having to use a resource or something to help them, we could actually adapt and actually do that. Because if you noticed, you've got a range of resources on your table. You've got the abstract with the number cards. You've also got the dot cards. And those dots have been arranged in a certain way so that hopefully you don't have to count the dots, you can see that. It's like when you roll a dice. When you roll a dice, we don't have to count the dots because we recognise that arrangement, we recognise that structure. So it could be, for some students, actually just by changing the resource, actually supports those mental calculations because they can see, visualise the number rather than actually just seeing an abstract number. The Numicon as well, I don't know how familiar you are, but once again, it's got that structure. They can combine those to help them make that sum to 15. All of what I'm talking about now is number sense, so they need number sense as well. Number sense is crucial. And we need to start that right at the very beginning because they need that if they're really going to understand and progress in mathematics. You've all been collaborating, so they need those collaboration skills. Curiosity. I hope I've got your curiosity. I hope you're wanting to play that game again to find out if there are other strategies. That's really important. You know, if you've got that curiosity, that interest, that motivation. And of course, developing a strategy. That's really important in mathematics as well. Now, all of those skills, I'm very aware that we do have students in our classes who struggle with mathematics. Because there are so many different strands of mathematics, and sometimes they might have strengths in some strands, but they'll have weaknesses in other strands. And that becomes a real challenge. I know when I've had my class of 30 plus students, I have a range of attainment within that group. And actually, for me to try and plan a lesson, deliver a lesson where every single student progresses with their learning, that can be really challenging. That can take hours of planning. So, here we have an image of a typical class. And like I said to you, that range of need that we have in this class, you know, this is the maths age distribution we could have within one class. Now, at Maths-Whizz, our data that we have actually confirms this. Not just in the UK, but actually within all of our territories around the world. There is at least a 4-year age range, and not age range as in chronological age, but as in attainment age. And that can be tricky. I've been to Kenya. I've just flown from Kenya to Dubai. I came a couple of days ago. And I went into really rural Kenya, just outside Mombasa, into Kilifi, where we're working with a lot of schools. I thought I struggled with 30 children. They can have up to 70 in their class. I know, my jaw dropped as well. It was like, oh my gosh, well, you can't do it. It's impossible. It's really difficult. Okay. So what I'm going to talk to you about now is how unique each student is. And are you familiar with the game Jenga? Yeah, you know you have all those blocks that you build this tower with. Now, I want you to imagine that this is a child. And actually each one of those blocks represents the concepts that they need to know and understand within mathematics. If we have blocks missing, that's gaps in knowledge. And I would guarantee that virtually every student in your class has probably got some of those gaps. The difficulty is, mathematics is so interconnected. For example, if a student is struggling with addition, but I'm moving on because the curriculum says, and I've got to teach the next part of my mathematics, and I introduce them to multiplication, if they haven't fully understood addition, and then I introduce multiplication, which is repeated addition, already we're starting to have problems. Then, of course, what's related to multiplication? Division. What's related to division? Fractions. You begin to see, I'm introducing all of these concepts, but if they haven't got the grounding of that, what's going to end up happening? Just like our Jenga tower, it's going to come crashing down. And quite often we have those students that actually start to switch off with mathematics. They've actually, because they feel they can't do it, they've disengaged. And or we end up having some students that go into adult life that have very low numeracy skills because those basics have not been secured. And what we need to try and do as teachers is address all of those gaps. And that's where the challenge comes. So, what I'm going to show you now is the virtual tutor. The virtual tutor is like a human tutor. And what it will do, first of all, is it will assess where the student is with their learning of mathematics. So it does an initial assessment, which is a diagnostic assessment, very low pressure, very interactive, very engaging. But what it will actually do for you as a teacher is it will pinpoint where all of those weaknesses are. And if you look at our student A here, I'm sorry, because I think of the projection it's not showing, but this is a grey bar here. Where you see these red bars, that's where the student is at within those different strands of mathematics. And if we actually look at it, it's not a nice rounded profile there. It's quite jagged. There are weaknesses and there are big strengths as well. But because math is interconnected, actually what we want is a much more rounded profile because then we can really progress with the students' learning. So how does it actually work? So the virtual tutor will do that assessment that I've just spoken about. And then what it does, depending on the response of each individual student, it will then tailor a learning journey specific to that child. Okay? But it's adaptive. So what I mean by that is, as the student progresses on that learning journey, depending on how the student responds, whether they're struggling or whether they're finding it easy and needing to move on, the virtual tutor will adapt and will actually give them the right lessons right for them at that point in their learning. But what, yes, sorry, yes. Yes. Yeah. Absolutely, totally, yes, it is. So, what's great, and I'm a teacher, I love this because, and head teachers have said to me, what I love is it teaches as well, because this isn't just games that the students are going to play now, it actually does teach. So it will actually teach a concept. It will go through, very similar to how you would teach it in the classroom. It's got those visual representations which are really important, because if we work in the abstract, we're going to struggle to develop understanding. We need to have those visual representations. We need to go through that Bruner model, concrete, pictorial, abstract. Really, really important. And here, so it's a bit blurry. Let's see if we can, so here it actually gives some instruction, but it's audio as well. When the tutor has done that teaching, and it's a guided practice where the student responds as well, it then moves on to an interactive exercise. And the student will have about 10 questions to answer. If on that journey the student really starts to struggle, then it will start to give prompts. So that's part of the prompt to begin with, and then if they're still really struggling, it will take them back and remind them what they've actually done in the learning, in the teaching part. And it will actually give them that prompt and support. If they still struggle, the tutor will actually decide to stop that and will actually take them back to a previous exercise so that they can build on their knowledge before they actually then move back to this exercise. And then, if they get 70% or above, the tutor's happy that they have a good understanding. It will then move them on to a very brief summative assessment, about 5 questions. And if you look, actually, it's slightly different now in how it's displayed, because we don't want to, we want to make sure they do have that understanding and it's not glorified with all of this interactive images and things. It will actually then just do it in a very plain way, just 5 questions just to see if they can answer those. If they can, and they get 70% or above, it will then progress them onto the next stage for their learning that's appropriate to them. Sorry, I'm still having a struggle. Now, remember that student I showed you? This is the student now after a couple of years. Look at that rounded profile now, where the tutor has addressed all of those weaknesses. And they're now, well, I would love students, a class of students that have a profile that's far more rounded. All those weaknesses have been addressed. It makes my life as a teacher far more exciting with all the creative things that we can get on with and all the problems that we can solve. So, we all want students like that, but that's how the virtual tutor can support us. Now, I'm going to say now, the virtual tutor is not there to replace any of us. It's there to support us, because particularly with Maths-Whizz, all we require is for the student to do 30 plus minutes a week. That's all they need to do, and they will start to progress. If they do 45 to 60 minutes a week, they will make accelerated progress. So if you think of our working weeks, that's not much time. So it's then going to support us in the maths lesson. What does it do for the student? I've tutored many students in my time, as well as teaching classes of students, and I find the biggest barrier to mathematics is attitude. They think they can't do it. They haven't got the confidence. The virtual tutor, because it's tailored the learning journey specific to that child, they start to achieve. And I have found when I've tutored one-to-one, parents say, Fiona, you've done the most amazing things. And actually, all I've done is I've made that child believe in themselves, that they can do it. We've done small steps progressing forward. And that's what I think is so important. And this is what the virtual tutor can do. It can bring mathematics to life. They start to enjoy mathematics. They get motivated with mathematics. But it's also given them that, all the key skills that they need to move forward. Let's go back to our game. Okay. I don't know if you've been playing it long enough, but I'm going to ask you a question now. When you were playing that game, there were two things you had to think about. You had to get 3 numbers that sum to 15, and you also had to try and block your opponent. You had to be very aware of what your opponent was doing. What does that remind you of? Tic-tac-toe. Yes, well done. Tic-tac-toe, absolutely. I was dreading no one was going to say anything then. So you're absolutely right. Now, let me show you how it works. So, if I had an interactive whiteboard, I could actually show you, move things around, which is far more engaging than actually watching a PowerPoint. But I haven't got that, so we'll have to go back to the PowerPoint. So, what's happening here? Can you see a line of 3? The hidden connection. So actually, sum to 15 is tic-tac-toe, noughts and crosses, whatever you call it, in disguise. And in order to get there, what have we done? We have actually used a magic square. Because if you look at this magic square here, all of the rows, all of the columns, and all of the diagonals sum to 15. So the big question is, this clicker, right. Is there a winning strategy? Okay, so can you go to your tablets, wherever you loaded that menti.com. And I'm just going to quickly exit here. Okay, could you enter the code 92392? And I want you to now vote. Is there a winning strategy in sum to 15? Yes or no? Don't you love how this is working? Students would love this in the classroom, wouldn't they? Fantastic. Okay, it's still going forward. Okay, I think we can say we have an overwhelming yes. So let's go back to our PowerPoint. So is there a winning strategy? Well, if you know noughts and crosses, actually there is a winning strategy because you need to get 3 in a line. And also the same with tic-tac-toe. I don't know if this happened to you when you were playing in your pairs, but you might have had 2 potential possibilities, the same as noughts and crosses. Or you may have had the scenario when you played this game that actually you drew. Now, who's familiar with tic-tac-toe, noughts and crosses? Okay, let's be really honest. It's a bit dull, isn't it? Because once you know the winning strategies, you're probably always going to end up drawing. So actually, my game to 15, my problem that I've given you, if we're not careful, could be quite dull. And what did I say at the beginning? It was a rich problem. So how could rich suddenly turn to dull? Well, that's because there are other things. Remember I said, actually we can take it to lots of different levels with our students. So we could actually, because we have that link with the magic square, we can start looking at magic squares. It goes back in Chinese literature to 2800 BC when the emperor saw a turtle coming out of the water that had this dot pattern on its shell, and then recognized that actually you could see what we now know as a magic square. So that's quite a nice little story to tell your students, but also it's the symmetries within magic squares that we can explore. Because if I got each of you now to use the number cards 1 to 9 and to complete a magic square, you might all complete it in a slightly different way. They're all going to sum to 15 still with the rows, diagonals and columns, but it will reflect one of those 6 symmetries that we have there. And that's really nice to explore with your students as well. Now, the only thing with magic squares is that we have a magic number. And I've actually told you that magic number today because it was 15. But if I gave you a different magic square to work out, how would you do it? Would you know the magic number? Because I wouldn't tell you. So if we had 3 1s, 3 2s and 3 3s, you could do it by trial and improvement. But what I would want students to start thinking about is, can I work out what the magic number is? So if we go back to our magic square, here, let's think about it. If we've got all the numbers from 1 to 9, if we add all of those up, it comes to 45. What's our magic number? 15. What are we using? A 3 by 3 grid. Are you seeing the connections now between 45, 15 and 3? Okay, so if we go back to this one here, if we add those up, it comes to 18. We've got a 3 by 3 grid, divided by 3. Our magic number is 6. Okay, but we can explore this even further. Because the other question I could work with my students is, does the center number have any significance? So let's have a think. We've got 45, we've got 15 and a 3 by 3 grid, and we have 5 in the middle. We've got 18. Our magic number is 6 in that 3 by 3 grid, and our center number is 2. Are you starting to see any relationship? Mathematics is all about that. I'm going to leave you to ponder that. We can actually work out our center number as well in a 3 by 3 grid, because actually magic squares don't stop there. Don't know if you've heard of the Gnomon magic square. Its magic number is 34. It's very famous. Google it, because not only does it have rows, columns and diagonals that sum to 34, it has a lot of other special properties as well. Absolutely fascinating. And there is a significance, I'm not going to give it away, with the 15 and the 14 as well. So go and have a little search. It's well worth looking into. We said tic-tac-toe was boring. Actually, have you ever played the ultimate tic-tac-toe. Believe me, it is so addictive. You have to think on so many different levels. Another really nice way to engage your students in the classroom. Because what we're developing there is we're developing their reasoning, their thinking, their logic skills, which is really important. It doesn't always just have to be playing with numbers. Now, I'm coming to the end. As well as the virtual tutor, what Maths-Whizz also supports you as teachers is we have a teacher resource. And I don't know if you've come to our stand yet, but we've got a competition today. Somebody said to me at the beginning that they felt they were going to have to answer a question or sign their life away. No, you don't. All you have to do is in your bags you have a little card. Complete that card and come and post it into our box, because we're giving away teacher resource, a subscription for Teacher's Resource for the whole year. Why Teacher Resource? What's all that about, Fiona? Well, actually, what it is it gives you 1,200 interactive lessons that you can bring into your classroom. It gives you an interactive whiteboard. It gives you extended problems, a bit like the problem that we've explored today. There's a dictionary. There are worksheets. There's a whole host of things that are going to really help save you time as teachers, because I hope you're like me, but anything that saves you a bit of time so you can focus on what you really want to do in the classroom is worth exploring. So, competition, go and enter. So, we've dipped in and out of technology today, and I've just really wanted to give you things to think about with regards to technology. The technologies that you're using, how it supports you in the classroom, and also I've obviously explained what I think is the future of mathematics, to really help us with, all these different needs of students that we have coming into our classroom. If we can actually have something that supports us as the class teacher, not replace us, but support us, then actually, the virtual tutor is something that I would really embrace. So, thank you for your time, and I hope that you take away at least one thing from this session. Please come to our stand and find out more. What I've also done for you, though, is I've actually, on our website, if you go there, you can download the problem that I've done with you today to take straight into your classroom. And I've also put up there some resources. So whether you wanted to do dot cards, number cards, the no-one squares there, tic-tac-toe, magic square grids, all of that's there to support you in the classroom. So you can download that from our website to use tomorrow when you go back into schools.